Adding and subtracting rationals in Algebra 2. So the first part of this, we're actually going to review how to add and subtract fractions without a calculator. And think back to elementary school, and the key thing you need here is a common denominator. So you need the same number in the bottom of the fraction. So if I look at number 1, I have 2/3 plus 3/4. I can't turn a 3 into a 4, and I can't turn a 4 into a 3. So what I have to do is I have to multiply it by a certain number that they each share. The easiest way to do that is to multiply both of them together. So 4 times 3 is 12. So I'm going to turn this first fraction, the bottom of it, into a 12 by multiplying the 3 by 4. But whatever I change on the bottom, I also have to change on the top. So 2/3 is really going to become 4 times 2 is 8 over 4 times 3 is 12. Carry down my plus sign. And now I'm going to change the bottom to a 12, so 4 times 3. And then whatever I do to the bottom, I also have to do to the top, which becomes 9 over 12. Now, since I have the same denominator, they're both 12, all I have to do is add the top, which will give me 8 plus 9, which is 17 over 12. And that's my answer. Now let's look at number 2. We have 4 minus 2 over 7. 4 isn't written as a fraction, but we can make it a fraction by putting it over 1. Now I have a 1 in the bottom and I have a 7 in the bottom. Well, I can very easily turn this 1 into a 7 just by multiplying it by 7, which means I don't even have to change the second one. Whenever I do to the bottom, and do to the top. So 7 times 4 is 28 over 7. Carry down the minus, and then we have 2 over 7. Then the easiest thing to do is change this minus sign to a plus and make the top of the second fraction negative. So now I'm going to do 28 plus a negative 2, which gives me 26 over 7. And finally, 3, we have 3/5 plus 2/3 minus 1/2. Now I see that minus sign, I'm going to immediately change that to plus a negative 1, just because addition is a little bit easier. So I have 3 numbers in the bottom now that I need to change to the common denominator. And again, the easiest way is if we just multiply them all by themselves. So 5 times 3 is 15. 15 times 2 is 30. So I need to change all of these into the number 30 on the bottom. So what do I need to multiply 5 by to get 30? I need to multiply it by 6. And so I need to do that to the top. And then the middle one, 3, I need to multiply that by 10, again to the top. And then the last one, I want to multiply it by 15, bottom and top. So that has created the number 30. So 6 times 3 is 18 over 30. Then we have plus 2 times 10 is 20 over 30. And again, we changed this to a plus. Negative 1 times 15 is negative 15 over 30. Now here we have to add 18 plus 20, which gives us 28. And then 28 plus negative 15 gives us a positive 13 over 30. So now we're going to do the same concept, but this time we have variables. So you need a common denominator before you can do anything. So looking at number 1, I have 3 over 2x plus 9 over 2x. Well, there I have a common denominator. So I can just add 3 plus 9 and get 12 over 2x. Now, this is not simplified. It's not my final answer because I can do 12 divided by 2, which gives me 6 over x. That would be my final answer. So here with the variables, we are adding and subtracting like we just did, but we also have to look because sometimes we can simplify them. And if you remember from last class or the previous video, we talked about how to simplify these rationals. So looking at number 2, I have 2 over 3 plus 1 over x squared minus 5 over x. So I have a minus, I want to change it to a plus, a negative. Now I'm going to make a common denominator. And again, the easiest way is to multiply them together. 3x squared, well, I can turn that x into x squared. So really my common denominator should just be 3x squared. So to make this, I need to multiply that by x squared, top and bottom. So again, I'm looking for a 3x squared for each one. So that already has an x squared. So we're going to multiply it by 3, top and bottom. And this one already has an x, so we're going to multiply that by 3x, top and bottom. So now, doing the top, I have 2x squared over 3x squared plus 3 over 3x squared. And then again, we changed it to plus. Now negative 5 times 3x is negative 15x over 3x squared. Then we look to combine our like terms on the top. Now for this problem, we don't have like terms, so we're just going to rewrite it in standard form, which is 2x squared minus 15x plus 3 all over my denominator of 3x squared. And we can just leave it there. We're not going to worry about factoring that or seeing if we can factor that right now. Okay, problem number 3. Here we have two binomials. Whenever we have an addition or a subtraction sign, we have to keep these together. So we're saying this first fraction has an x plus 2 on the bottom, and the second fraction has an x plus 1 on the bottom. So I need to multiply this first fraction by x plus 1. So now they both will have an x plus 1. And again, top and bottom. I need to multiply the second fraction by x plus 2. So they both have x plus 2. Again, whatever I change on the bottom, I have to change on the top. So when I distribute the top, it becomes 2x plus 2 over, and don't FOIL the bottom. We're just going to leave it as x plus 1 times x plus 2. Carry your plus sign down. Again, distribute the top. We have 3x plus 6 over x plus 1 and x plus 2. Then we just look to combine our like terms. So we have 2x plus 3x, which gives us 5x, and then 2 plus 6 gives us 8 over x plus 1 and x plus 2. And that's our answer. We're just going to leave it like that. All right, problem number 4 gets a little bit different again because here we're dealing with x squared. Whenever we see x squared, we're going to have to factor. This is luckily a difference of squares. So it's an easy factor. So I'm just going to go ahead and factor that. So this becomes 5 over x plus 4 and x minus 4. Then I see there's a minus sign, so I'm going to change it to plus, change the 3 to negative. I'm just going to rewrite that as plus negative 3 over x plus 4. Again, I need a common denominator. They both have x plus 4. So the second fraction needs x minus 4 for it to be the same. And again, whatever I change on the bottom, I have to change on the top. So now I'm going to distribute. I didn't do anything to the first fraction, so I still have 5 over x plus 4 and x minus 4. We have plus now. After I distribute, it becomes negative 3x plus 12 over x plus 4 and x minus 4. Last step is to combine your like terms, which is 5 plus 12. So I still have negative 3x plus 17 all over x plus 4 and x minus 4. And that would be my answer. And finally, we have problem number 5. Again, I see an x squared, so I'm going to have to factor, so that's what I'm going to do first. I'm going to rewrite my first fraction of x over x plus 7, and then plus. Now, I'm trying to think what multiplies to 14 but adds to 9, which is 7 and 2. And this is an easy factor because there's nothing in front of x squared. So it becomes 4x over x plus 7 and x plus 2. So my first fraction has an x plus 7 and my second fraction has an x plus 7. But my second fraction also has the x plus 2, which means the first fraction needs x plus 2 as well. So I'm going to distribute. I'm going to get x squared plus 2x over x plus 2 and x plus 7. Then we have plus, and then my second fraction of 4x over x plus 7 and x plus 2. So now I have a common denominator, and I'm just going to combine my like terms, which is just 2x plus 4x. So that's going to give me x squared plus 6x over x plus 7 and x plus 2. And that would be my final answer for number 5. So again, if you need to rewatch this or pause the videos, please do that or come see me and I will help you out too.